Ever catch yourself wishing you could just like talk to your computer directly,
Wow.
get it to do stuff without all the clicking and typing and menus?
Like you want to just skip to the good stuff, straight to the commands.
Exactly. And that, my friend, is where bash scripting comes in. It's like learning your computer's secret language.
Unlocking a whole new level of control.
And that's exactly what we're diving into today. We're using Linux Basics for Hackers as our guide.
Don't let the title scare you, though. We're not turning anyone into a black hat hacker today.
Right. This book just happens to be a really great resource for understanding the power of scripting. Specifically, we're focusing on Chapter 8. It breaks down how even simple commands, the kind you might type into your terminal, can be strung together to build some really cool stuff.
Like, think about scripting languages like Ruby or Python.
Oh, right. Ruby's what's behind the Metasploit framework, isn't it?
Yep. And Python's used in a ton of hacking tools. They're both super powerful.
So where does Bash fit in? Is it similar?
Kind of. But what's cool about Bash is that it's already there on pretty much every Linux and UnionIX system, even macOS.
No need to install anything new.
Nope. You're just tapping into what's already built in. It's like learning your computer's native tongue.
I like that. No more relying on those user-friendly buttons and menus. We're going full command line, huh?
Exactly. We're dealing with the Bash shell specifically. It's like the classic, the reliable one in the shell world.
Okay, so we've got our shell, which is like our command center. What about the actual commands, the tools we use to actually write these scripts?
Well, we'll be looking at commands like echo.
Echo, what does that one do?
Pretty simple, actually. It just repeats back whatever you tell it to.
And then there's read.
Right. That one lets us take in information from the user. Like if you wanted the script to ask for your name.
I see, I see. So these commands seem pretty straightforward.
Oh, they're the building blocks. It gets way more interesting when you string them together. But before we get to that.
We need to talk about how to actually write these things down, right?
Exactly. Just like a writer needs their notepad, we use text editors to write our scripts. Things like Veeam, Vim, or Emacs. Real hacker favorites.
And once we've typed it all up, save the file. That's it. Ready to roll.
Not quite. We got to tell the computer that this file, it's not just any file, it's a script, and it's got permission to run.
Let me guess, there's a command for that.
You bet. That's where chmod 752 comes in. It's like giving the script permission to actually do its thing.
So it's like flipping the switch to bring our script to life.
You got it. And trust me, forget this step, and you'll get an error message faster than you can say segmentation fault.
Okay, let's definitely try to avoid those error messages. So now that we have all this in mind, should we try building a simple script? See how these commands actually work when we put them all together?
Let's do it. And the best place to start is with a classic, the Hello World of scripting.
Hello world. What's that?
It's like the most basic script you can write. It doesn't really do anything, just prints out a message.
Oh, okay, so like a practice run.
Exactly. Helps us get a feel for the basic structure. It's like how to tell the computer what we want it to do.
All right, sounds good to me. So where do we begin?
We got to tell the computer which interpreter to use. It's like choosing the right language for a conversation.
Yeah.
You know.
And in this case, our language is Bash, right?
Right on. And we tell the computer that by starting the script with a special line. It's called the shebang.
Shebang. What is that, some kind of technical jargon?
Kind of, but it's just 2 characters.
Yeah.
Hashtag. Then you put the path to the bash interpreter, which is usually bin bash.
Okay, so it's like we're saying, hey, computer, this is Bash. Use Bash to run it.
Exactly. Without it, the computer might try to use the wrong interpreter and get all confused.
Right. Makes sense. So we've got our shebang. What's next?
Now the fun part. We use the echo command to actually print out our message.
Which would be, hello, world.
You got it. So the whole line would be echo, hello, world.
I noticed you put quotes around hello, world. Are those important?
Oh yeah, those quotes are crucial. They tell the system that everything inside them, even if it has spaces, is all one single string of text.
Okay, so the quotes tell the computer to treat it as one whole phrase, not separate words.
Exactly. And to run this whole thing, we save it as a file, usually with a .ch extension.
So like, hello, Tesh.
Perfect example. Then we got to make it executable, remember?
With chmod 755.
You got it. chmod 755 hello.sh. Then in the terminal, you just type hello.sh and hit enter.
And that's it. Our script runs.
Boom. Hello world. Right on your screen. Now, the book takes this whole hello world thing and gives it a bit of a hacker spin.
Oh, how so?
They have a script called Hello Hackers Arise. Same concept, different message.
Catchy. But I guess it's still using the same basic commands.
Yep, but it also introduces this idea of comments in code.
Comments, like leaving yourself notes.
Exactly. You use the hashtag symbol, and anything after that on the same line, the computer just ignores it.
So we can write whatever we want there. Explanations, reminders, inside jokes.
Go wild. It's super helpful for explaining what your code does, especially if it gets complicated. Or if someone else needs to understand it.
That's smart, like leaving breadcrumbs in case you forget what you did.
Exactly. A well-placed comment can save you a lot of headaches later on, trust me.
I bet. So we've got our hello world, we've added some comments. What's the next level up from here?
Well, so far our scripts have been pretty static, just spitting out the same thing every time. To make them more dynamic, more interactive, we need variables.
Variables. Okay, now you're losing me a little bit.
Think of them like containers that hold information. You give them names, and then you can put stuff inside them. Numbers, text, even whole files.
So it's like we're giving the computer a little box and saying, hey, remember this for later.
That's a great way to put it.
Yeah.
And to actually get information into those boxes, we can use the read command.
Oh, right, the one that gets input from the user.
Bingo. Let's say we want a script that greets you by name. We can use read to ask the user for their name, then store it in a variable.
So the script would be like, what's your name? And then it waits for the user to type something in.
Exactly. And once they hit enter, bam, their input is stored in that variable, ready for us to use.
Okay, so how do we actually use it? Like, let's say we've stored the user's name. How do we get the script to actually say, hello, their name?
That's where echo comes back in. But instead of putting the message directly in quotes, we use the variable name and put a $sign in front of it.
So it would look like echo hello name if our variable was called name.
You're a natural. And when the script runs, it sees that name and swaps it out for whatever the user typed in.
Wow, that's really cool. It's actually having a conversation with the user.
Right. And this is just the beginning. Variables can do so much more. You can store different types of data, manipulate text, do calculations. The possibilities are endless.
Okay, now things are getting really interesting.
And speaking of interesting, our source material uses a real-life hacker as an example.
Wait, a real hacker?
His name is Max Butler, but he went by Max Vision in the hacker world. He was like a legend, kind of a gray hat, meaning he did good things and some not-so-legal stuff.
Okay, now I'm really intrigued. What did he do?
Well, this guy Max, he discovered a back door in the Aloha POS system.
Aloha POS, like the system they use at restaurants.
Yeah, tons of restaurants used it. And this back door, it was supposed to be for remote tech support, accessible through port 505.
A back door, so like a secret entrance that anyone could use.
Kinda, yeah. Meant for good, but Max figured out how to exploit it. He was after credit card data.
Yikes, that's scary, especially since we use those systems all the time. But did he use a script to do it?
He did. See, manually checking for that open port on millions of systems, that would take forever. So he wrote a script to automate it all. Scanned IP addresses to find vulnerable Aloha systems.
Wow, that's impressive, but also kind of terrifying. Really shows you the power of scripting.
No doubt. Powerful tool. Like any tool, can be used for good or bad. But enough about the dark side. Our source uses this example to teach us how to build a port scanner too.
But for ethical hacking practice, right?
You got it.
Okay, so what kind of port scanner are we building? So this port scanner, it's looking for systems running MySQL, is that right?
You got it. MySQL is a really popular open source database system.
Okay, so our script is going to try and find these MySQL systems out there in the wild.
Exactly. It's a great example, shows how a simple script can be used for like network exploration.
Okay, I'm definitely game for some network exploration. So how does the script actually work?
Well, it uses a command called unmap.
Unmap. That rings a bell.
It's like the ultimate tool for network scanning. Lets you probe systems, see which ports are open, gather info.
Sounds powerful.
Oh, it definitely is. But remember, Nmap, it's a neutral tool, right? It's all about how you use it.
Right, in the wrong hands.
Could be used for malicious stuff, sure. But security professionals, they rely on it all the time, finding vulnerabilities, securing systems.
Right, of course. So we're using it ethically just to see if we can find these MySQL systems.
Exactly. And the key is MySQL usually runs on a specific port, 3306. So our script uses Nmap to scan a bunch of IP addresses, see if any have that port open.
Makes sense. But I'm guessing there's a little more to it than that. Can we look at the actual code from the book, the MySQL scanner.sh script?
Absolutely. So first line, you guessed it, that's our shebang. Tells the system to use the bash interpreter.
Got it. Then we get to the actual nmap command.
Yep. The script uses Nmap with the NST flag.
The what flag? Sorry, you lost me.
The TCT flag. It tells Nmap to do a specific type of scan, a TCP connect scan. bit more reliable, but also might be logged by the target system.
Logged. Like, someone might know we're snooping around.
It's possible,
Hmm.
especially if they've got tight security. But for our purposes, just for learning.
Educational purposes only.
Exactly. So we've got our scan type. Next, we got to tell Nmap which IP addresses to actually scan. The book gives a specific range.
Okay, and then what? The scan runs, spits out a ton of info.
Way too much to make sense of. That's where things get a little sneaky. The script uses this symbol. It's called a redirection operator.
A what iterator?
Redirection operator. Basically, it takes the output of the Nmap command and sends it somewhere else,
And where does it go?
to a special place called dev null. It's like a black hole for data. Anything sent there, poof, gone.
So we're running the scan, but we're not actually looking at the results.
Not the full results, no. We're only interested in one thing. Is port 3306 open or not? That's where grep comes in.
Ah, grep, our search buddy.
Exactly. grep lets us search through text for specific patterns. In this case, we're looking for the phrase 3306 TCP open MySQL.
So it's like grep is digging through all that scan data, even though we sent it to the black hole.
Yep, and if it finds that specific phrase, it means boom, we found a system that's probably running MySQL.
That's pretty slick. But I think the book mentioned something about making the script even more interactive.
You're good. Yeah, right now it's set up to scan a specific IP range and port. But what if we want to change it up?
Would we have to, like, edit the code every time?
They get old fast. That's where user input comes in handy. The book shows us how to modify the script to ask the user for three things:
Pit me.
the starting IP address, the last part of the final IP address in the range, and the port number.
So we're basically asking the user for the info we need before running the scan.
Bingo! We use read, remember? Get those values from the user, store them in variables, and then we plug those variables right into our Nmap command.
So much more versatile. We can reuse the same script for all sorts of scans.
Exactly. That's the beauty of scripting right there. A little bit of code goes a long, long way.
So we've gone from the very basics, what a shell is, how to use simple commands, to building a customizable port scanner.
And we saw how those same concepts, they can be used ethically or, not so ethically, like Max Butler and his credit card scheme.
Right, which is a good reminder for all of us out there. Knowledge is power, folks.
Yeah.
And it's our responsibility to use it wisely.
Couldn't have said it better myself. Learning about this stuff, even just the basics, it helps you understand the digital world better. Protect yourself from threats.
Totally. Well, on that note, I'd say we've done our deep dive for today. Explored the world of bash scripting, built a cool tool.
Even learned about a real-life hacker.
If you're listening and you're intrigued, definitely check out Linux Basics for Hackers. Great resource, whether you're just starting out or you're ready to level up your skills. Until next time, happy scripting, everyone.